All right, so in class we first defined what it meant for something to be a subspace, and I've copied that definition here. And then we had two problems with a definition of a set in each, and then the question was to determine whether or not that set was a subspace. And so here's the second set. This was problem number 2 on the 4.8 practice problems. And it says, let H be the set of vectors of the form A, 2A, 3A, such that A is some real number. And so another way you could think of this is for a vector V in H, V is equal to a vector A, 2A, 3A, which I'm also going to write. I can factor out that scalar A as 1, 2, and 3 times A for A in R. And I'm going to say that this second form will actually make it a little easier for us to argue that this is a subspace. And so if I want to do this argument, I just need to check each property in the definition. So for property 1, I need to show that 0 is in my subspace. And again, I'm going to use this form right here to describe all vectors in my space H. And I'll say let A equal the number 0, then 0 times the vector 1, 2, 3 equals the 0 vector in R3, and that's in H. So that tells me that property 1 is satisfied. And property 2 says that if I have U and V in H, U, V in H is U plus V. So for this, let me again use my definition. So I'll say let U and V be in H, and let's let U be equal to A times 1, 2, the vector 1, 2, 3, and V equal B times 1, 2, 3, where A and B are in R. So that meets this pink definition here. Then U plus V is equal to A times the vector 1, 2, 3 plus B times the vector 1, 2, 3. But we know that this is equal to A plus B times the vector 1, 2, 3 by our distributive property. And let me insert another page. Of course, in the wrong spot. Let me come down here and try that again. Sorry. Insert pages, blank page. There we go. All right. And here I can say that since A and B are real numbers, A plus B is also a real number. Therefore, A plus B times this vector 1, 2, 3, which is equal to U plus V, is in H. So there's property 2. Property 2. And the last one is property 3, which says that if U is in H and C is in R is C times U in H. So again, I'm going to let U be an element of H. Then I can write U in this same form again. U is equal to A times the vector 1, 2, 3, where A is some real number. And then I get that C times U is equal to C times A times 1, the vector 1, 2, 3. And because of associativity, I can write this as C times A times 1, 2, 3. And then just as above, since C and A are real numbers, C times A is in R. Therefore, C times A times this vector 1, 2, 3, which is equal again to C times U, and that's in H. And that's property 3. So we go back here, and I've satisfied all 3 properties. So then I can say, since H satisfies properties 1, 2, and 3 of my subspace definition, H is a subspace of R3.